hopefully if you noticed, almost everything in this chapter has been something you've previously done in your math courses. So we're really just kind of reviewing it and just building on it just a little bit. Well, section 6, we're starting to talk with 2 variable data. So all the first 5 sections deal with 1 variable data, right? We're just looking at like 1 statistical piece of information, right? Contains measures of only 1 trait of quantity. Where 2 variable data, now we're looking at quantities that have 2 traits. So for our data has 2 traits. So the main example are things that we end up graphing on a coordinate plane with the use of like a scatter plot. And a lot of times, one of the most common ones is for like speed, when you're checking, how far you're going over a certain amount of time, right? So I can't just plot that on like, with our 1 variable data, I could just do like dot plots, Well, I can't do that if I have speed because I have 2 things for speed. I have a distance and I have time, right? And so that's where it comes into play where we need, like an L graph or actual coordinate plane, things like that. So first of all, let's just review what a coordinate plane is. Remember, our coordinate plane is made up of 2 axes. We got our x-axis right here, and we got our y-axis that goes north and south. So hopefully we remember that from previous. And then the nice part, where they cross is at this point 0, 0, right? And there's a term that we use for that. Does everybody remember what that term is? Starts with an O. Yeah, that is called the origin. Okay, because it kind of like, that's where it originates. That's where everything is based off of, is that point 0, 0. All right, what are some other things about the coordinate plane that we know? Well, we have 4 sections, right? We got this guy up here, this guy here, and what do we call these guys? Quadrants. All right, so those guys are all called quadrants. And if you think about it, where would quadrant 1 be? Where would we start for graphs? Well, some people think, well, you just work left to right, so I should work at this top left one. But think about, where do you graph mostly? Usually you graph with positive values. Well, where are my positive values at? That's right, this top right one. So this one is actually quadrant 1. And we use Roman numerals a lot of times, so that's quadrant 1 up there. So remember, and that should make sense because that's where my values are both positive, right? Oh, I should talk about my ordered pairs. Well, when we write an ordered pair, we put parentheses and a comma in the middle. What comes first, the x or the y? That's right, the x comes first and then the y, right? It's alphabetical. So quadrant 1 is when both are positive. So let's just look at a point, for example, here. If I just I'm going to take my blue and I'm just going to go right here. So what would that coordinate be? I'm going to call this guy the letter A. A lot of times we don't actually write the coordinate on the graph. We just put a letter so it looks a little nicer. So if I put A over here and I wanted to name this point by its coordinate, what would I say? Well, we always start from the origin and we count our x first. So it's going right 1, 2, 3, 4, 5. So it's positive because we went right. So that's 5. And then it goes up how many? 1, 2. So it's going up. So that's also positive. So that'd be the point 5, 2. So remember, quadrant 1 is where both are positive. And then we work, it's kind of goofy, we actually work counterclockwise. So we go left over here next, and that would be quadrant 2, followed by quadrant 3, followed by quadrant 4. And I got Roman numerals for all those. And I'm also going to write what positive and negative numbers go with that. So for example, in quadrant 2, which one becomes negative, the x or the y? Well, if I look from the origin, we're working left, well, that's the negative direction, right? So my x is going to be negative, and my y will be positive now. Whereas in quadrant 3, they're both negative numbers. And then in quadrant 4, we have a positive x and a negative y. Okay, so hopefully this is just kind of reviewing some things you already know. So the main keys is know where the quadrants are located, know what the axes are called, which one's the x, which one's the y, how to actually write a coordinate, things like that. So let's just say I'm going to put a couple more points in here. Let me grab this point right here, and I'm going to call that B. So if I did B, if we take a look, that's located in what quadrant? Yep, quadrant 3. And what would its coordinates be? So base it off of 0, 0. So we're going left 1, 2, 3, 4, 5, 6. So that'd be negative 6 as it went left, and down 1, 2, negative 2. That would be that coordinate for that. But what if I drew something like this? What if I put a dot right here? Is that in a quadrant? No, it's not. I'm going to give it a letter. So that doesn't lie in a quadrant at all. So if I were to ask you, well, where does C lie? If I said, where does C lie on the coordinate plane? How could you describe that? Yeah, C would lie on the y-axis. So if it lies on the y-axis, what would its coordinate be? Well, let's start from the origin. Did it move left or right? No. It just went straight down. So it doesn't move left or right. So it's 0 for the x, and then the y, it goes down 1, 2, 3, 4, 5, 6. Went down, so it's negative, and 0, negative 6. So just being able to describe where points are located, all those types of things. So let's get some practice reading some two-variable data. So this graph shows the distance from a motion sensor to a person varies over a period of 6 seconds. Describe where the person is in relation to the sensor at each second. Okay, so from 0 to 1 second, what is occurring here? Well, let's take a look. Let's look at my graph. Okay, so at 0 seconds, it looks like I'm right here, and then at 1 second, I'm right here. So first of all, was I right next to the motion sensor, or was I a distance away from the motion sensor? Well, here's your distance. So at 0 time, it looks like right here, I was 2 what? 2 inches, 2 feet? How can I tell? Yeah, look at your label. It says M, 2 meters. So you began 2 meters away from sensor. And did you move at all? Let's see, it goes straight across. No, I'm still at 2 meters. So then you did not move. Began 2 meters away from sensor and did not move. So you stood still, or you could say you stood still at 2 meters away, some things like that. Okay, so let's go from 1 second to 2 seconds. What occurred? So here I'm at 1, 2, still the same thing. Stood still, 2D. Oh, there you go. Stood still, 2 meters away. Something along those lines. All right, moving on. 2 seconds to 3 seconds. Now, what happened? We walked a meter, right? We walked 1 meter away to be a total of 3 meters away. So I was very specific. You don't have to be that specific. You could say you walked to get to 3 meters away, or you walked 1 meter in that second. You know, just describe something that I can tell. And the same thing occurs from 3 seconds to 4 seconds, right? So I'm going to go 3 to 4 seconds, walked another meter. And lastly, you could combine these two. I'm okay with that. So from 4 to 6 seconds, the same thing happens. What do? Do we walk closer to the sensor? Do we walk further away? Or do we stand still? Well, it's flattened out, so you didn't move at all. So we stood still. Stood still 4 meters away. Okay, so understand what happens, when the graph rises, when it flattens out, when it goes down, all those types of things. So let's go ahead and create our own scatter plot now. Let's get some practice at that. So for a scatter plot, anytime we're working with all positive numbers, we don't need the entire coordinate plane, right? I don't need this whole thing. We're just going to use an L graph, just like this. Make a little L, and go ahead and put a title and your labels on it right away. So my title is right here, that table. So phone call costs. And which one do you think would go on the x-axis? Usually they list them in order, but always know that time always goes on the x-axis. I'd say like you can almost guarantee that it's always going to go on the x-axis. So that's on the x, and that one's on the y. So we're going to label those guys. So x-axis, I have length of call. And it's very important to put minute so we know what we're talking about. And then for the y, we're going to put cost of call. So I'm going to go vertically here. And that's in dollars. There we go. So now we got to make our scales. Well, can I start at 0, 0? Is that okay, or do I need to make a break in the graph? Let's see. Our length is at 3 minutes and our cost is 150. Yeah, I would say we can start at 0, 0 here. That's perfect. So what about the length of the call? We're going all the way up to 30. So should we count by 1s, 2s, 5s, 10s? Yeah, maybe 5s would be okay. So I go 5, 10, 15, 20, 25, 30. There you go. And I don't need to label every one. I could go every other just so we can tell that each dash is 5. What about the cost? We're going all the way up to 15, it looks like. So should I count by 5s with that one as well? That would only give me 3 dashes. Maybe I could count by like 250s. That would be kind of nice because then we have some decimals. So 250, 5, 750, 10, 1250, 15. And I can mark those. So 250, 5, 10, and then 15. So you don't have to write every single thing down, but you should be able to tell how it's going. And then for a scatter plot, well, it's just scattered plots, right? So it's just dots all over the place. So here's my first one. That would be the ordered pair what? 3, 1.50. So I got to go 3, which is a little bit in front of the 5, and then I got to go up $1.50, which is a little over halfway. So about right there. That would be that point. I'm going to actually write that one in. I'm going to put 3, 1.5 so we can see that. Okay, let's go ahead and do the next one, 5, 240. So now we're right there. So put that green, should be just below. It's kind of tough. As long as you're somewhere in the vicinity, that's good. Then we got 12, 5.55. So we're looking, somewhere right there. And then we got 19, 870. So 19, 870 should be a little, somewhere about there. So 19, it's coming up over here. And then 870, that's a pretty good region, right? So as long as they're pretty close. Followed by 23, 10, 50. And lastly, we got 30, 15. So 30, 15 way up at top. So there we go. So just make sure that you have a title, labels for your X and Y axis, a good scale for each, right? So on the X, I counted by 5s, and on the Y, I counted by 2.5. And then make sure you have your dots for each coordinate from your table of your data. And that's all there is to it.